So we just switch the variables. Now how would we go about solving for y? What would we do to x equals 4y plus 2 to get y alone? What would be our first thing to do?
Subtract the 2 from both sides.
Subtract the 2 from each side, so make it x minus 2 equals 4y. And then how do we get it to be just y? How do we get rid of the 4? Divide each side by 4. So we'll have y equals, and typically we put it in the mx plus b form. So 1/4 x minus 2 over 4 we could reduce to 1/2. Do you follow all right where I came up with that? So that means that f inverse of x is equal to 1/4 x minus 1/2. And if we go back and look at our graph for a moment, I know we didn't use graph paper, so it may be hard, but I'm looking at the equation. My y-intercept should be, what's my b for my equation? Negative 1/2. And look where my green line went through. Negative 1/2 is my slope. 1/4 up 1 over 4. Looks pretty close to that without stopping to count everything. And you may see in the book some reference to verifying them. We're not going to do that this year. We're saving that for pre-cal. So you get to wait till next year to verify them. So let's try and see if we can find the inverse of another one. So number 2, can you find the inverse of f of x equals 2x minus 1? What's the feeling? Tackle it on your own? Or do we need to talk through it together? What's your comfort level? Give me a hand if you want help. Okay, it looks like we're all going to try it on our own. So as you're trying it, I'll kind of put it up here. Don't peek up until you're done, but then when you're done, look up and we should hopefully agree. How are we doing? Success? And is everybody okay with the 1/2? Or is that throwing anybody for a loop how we're coming up with the 1/2 and the 1/4? So I know sometimes you get mixed up, but it's really, there's a 1 in front of the x, so 1 divided by 2 is 1/2, and then the x. So far, so good? Yes? Then on for an application, and that'll be our last example for today. So example number 3, a small company produces greeting cards. The cost C in dollars of producing producing n greeting cards per month can be modeled by the function C equals 360 plus 0.60n. And our first task here is to find the inverse of the model. And there's going to be one slight variation that we do things a little bit differently when we have a word problem or a model as opposed to just a function. Because here we just switched the x and y and they didn't really have that much meaning. Here, C means cost and N means number of greeting cards. So if we switch the variables, we're going to have to redefine things and that would get complicated. So for word problems, you keep the variable, just solve for the other. So what that means is we're going to take our equation, C equals 360 plus 0.60n, and we're just going to solve it for n and not worry about switching the letters. So what's our first step to get the n alone? We've got to get the 360 over. So make it C minus 360 equals 0.60n. Then what? Divide by 0.60. So we are going to have that C divided by 0.60 minus, what do we get if we take 360 and divide it by 0.6? What are we going to get? 600. 600. So C divided by 0.60 minus 600 is equal to n, would be our inverse function. So in the original, we were able to take the number of greeting cards and figure out the cost, because the cost was written in terms of the number of cards. Now we have the number of cards written in terms of the cost. So if I gave you the cost, you could quickly find the number of cards, which leads us right into part B, which asks you to use the inverse function to find the number of greeting cards produced in a month in which the company's total cost was $615. So it says use the inverse. So we're going to use the C divided by 0.60 minus 600 equals n. And we're going to replace C with 615. So we'll do 615 divided by 0.60 minus 600. And 615 divided by 0.6. 1025 minus 600 is 425. So how many cards were produced if their cost was $615? 425 cards. So making sense so far with the inverses? We saw how to come up with it. We saw a use behind it, how in some function you might want to go the other way as opposed to going forward. So that wraps up the first part of 6-4. We will finish up 6-4 tomorrow.